Hi, this is the second video in a series for showing you how to use Tellurium, our simulation Python package. They're going to be pretty short videos. So the first video went over installing Tellurium on the Mac or Windows, or even using it online via Colab. So in this one, we're going to start using Tellurium. So I'm assuming that you've got Tellurium. I'm going to happen to use Spider, but you can use any environment you want. It doesn't matter. I'm using Spider because that's what I'm used to, and I like the fact that I have an editing window here. I have lots of tabs. We have different projects going at the same time. Then I have an interactive prompt here. For example, like 2 + 4 gives me six. And top right-hand corner, I have the display window for plots and so on. So the first thing I'm going to do is how do I import Tellurium? So you can type it into the editor here, like this. And we generally shorten Tellurium to TE. So import Tellurium as TE. Okay, so the name of the package is Tellurium, but I'm going to shorten it to TE. You can either do it there and run, right? That'll run it, or you can just do it directly here at the prompt as well. And so that's all you have to do to import it. Now that I've imported it, let's do something. Let's check the version information, see what we have. So I just type TE get version info, and I get all this stuff here. So the important thing, I guess, is that you're running Roadrunner 2.31, or anything higher or lower is okay as well. And this is my version of Tellurium I'm running. Okay, so that's basically how to import it. What about loading a model? Well, that's pretty easy. I'm going to type this first, and I'll show you what it all means. Okay, so I'm just typing this thing here. Now, if you're on Windows, when you do new in Spider, you'll get a template, and the template will already have all this stuff here for you. But if you don't, you'll type it in yourself. So what this is this is running a method called load A in Tellurium. And the load A stands for actually load antimony, and antimony is a language for describing biochemical networks. I'm not going to go into it in too much detail in this video, but we'll cover it more and more detail as we go on. But what I'm going to do here is I'm going to type in a really simple model. So the nice thing about antimony, it lets you type in reactions like you'd see them in textbooks. So here I have a chemical A. I can call it whatever I like. I just have to call it A. The chemical A gets converted to chemical B. Okay. So this could be, glucose getting converted to lactate or alcohol or whatever you want. I mean, that would be that includes all sorts of reactions, but let's not worry about that. So I have a chemical reaction here, A goes to B, and then I would put in maybe a little simple rate law that describes how fast that reaction will go. And in this case, is going to be, if you remember your chemistry, I'm going to have a rate constant K1 times the concentration of A. Okay, and that's basically how I define a model. All right. Now, one thing I will mention here is this reaction here is what we call irreversible. That means it only goes in one direction. What happens if I wanted to go in the other direction too? There's two ways to do that. I could either put in another line that says B goes to A. I won't bother doing that. What I'll do is I'll just make the rate law reversible itself. So I'll just so the reverse rate is K2 times B, and because it's reversed, I have to subtract the reverse rate from the forward rate. Okay, and so that's my model. All right. Let's quickly just go over. Let's say I want to actually run the simulation. For now, let's just do the simplest thing possible. I just type rsimulate, and then the last thing I want to do is plot the results. We'll go into more details on these in a later video, and that's it. What happens if I want to run this? Well, to run it, I go up to the toolbar up here, and you'll see I have a green button here. I just click that. Okay, there's an error. That's good. Actually, it's good. It's a good thing to see here, so I can tell you what's going on. It says global parameter K1 is missing a value, and indeed, that's absolutely right. I never gave any values to any of the parameters. So let's put some values to the parameters. I just made some up there. And we also need an initial concentration, so let's do that. Now the units of these concentrations are entirely up to me. I'm going to pretend these are millimolar. All right. So now I've got that set up. Let's hit the go button again. And now you can see I get a simulation. Okay, it shows me A declining, B rising. Seems to make sense. And that's basically a simulation. Okay, we'll leave that there now.